Well, good evening, everybody. This is the first of 3 webinars on what we call small wind or distributed wind energy systems. And we're going to be looking at the potential of small wind systems this evening. Our usual presenter who drives these systems Minx from the Institute won't be available, so I'm going to host and drive the system. If we get things right, we won't have any glitches. What I can tell you is that on the bottom left-hand side of that image, there's a QR code. If you scan that on your cell phone, that'll take you to the Institute's TV channel on YouTube. So that's a YouTube link, and you're welcome to scan that in and at your leisure have a look at our YouTube channel. Probably about 50 videos there, some good material, including a 4-hour video on the latest battery energy storage conference that was held in Pretoria probably about 2 weeks ago. So I think there's a lot of value there. I can see we've got probably about 170 people registered, and people are still streaming in, and we're certainly hoping to reach about 50 people. That would be a pretty good number statistically. So without further ado, I'll just do a quick introduction to myself. I'm a consulting electrical engineer, having worked for many years now on energy systems. I'm a member of the IEEE, the Smart Buildings Task Force. I'm a member of SAIEE, the Chartered Institute of Building Services Engineers. And then for the last 15 years, I've been a committee member with a funny bunch of people called the BIPSA, the International Building Performance Simulation Association. Half of them architects, half of them engineers. So architects and engineers get to rub shoulders as equals. And we're looking at green buildings, and I've worked on a number of green buildings. Okay, so how did we come about the set of 3 webinars? It all came about probably 2 years ago when we noticed the IEA set up a task force, a task group looking at the use of wind in a distributed energy future. Now, DER, or distributed energy resources, can be anything from batteries to PV, mostly PV, and of course wind. It doesn't always seem that we'll see a lot of small wind. We're so used to all the media focused on these big offshore units and the units around the Western Cape, Eastern Cape, but there is a growing market for the smaller units, especially where they're located on site, on farms, on industrial sites, as we see in the UK, for example, and they typically provide power to the site itself, local generation. We call it behind the meter energy resource. The reason why I think it's going to become far more popular is simply because we'll soon all be driving electric vehicles. My gut feel is that your next car that you buy new will probably be the last petrol or diesel vehicle you're ever going to own. Thereafter, the chances are you're going to have a Chinese electric vehicle, and they're brilliant. If you go online, you'll find some incredible buckies, 4x4s, sports cars. The Chinese are churning them out. They have some of the biggest factories. So how do we charge these vehicles, especially overnight? Because you don't drive overnight usually, and we need wind. Solar is great, but we need wind, and a lot of wind. So I'm hoping we're going to see a lot more distributed wind, and that's what we want to cover in these next 3 webinars. The interesting thing is that there are some certified, meaning I guess quality guaranteed, performance guaranteed turbines available to us. For example, there's the Berge XL10 and the 15, and we're very lucky to have Mike Berge with us tonight to talk about that. And on the far right there's the Everready, or the Kestrel. That's a little 3 kilowatt rated unit made in South Africa. We're hoping to get them on board as well. So South Africa are probably one of the few countries in the world manufacturing these certified units, and that puts us in a good place. And then lastly, I want to say webinar Wednesday number 2 on profitable small wind turbines is taking place in March. You're welcome to log in, register for that. And there we're going to do a techno-economic analysis of a system consisting of wind, of solar, and of diesel genset connected to the grid. We'll do a time of use tariff. We'll probably look at a farm in the Western Cape and a industrial park elsewhere. So we'll try and start looking at the numbers, the costs, put money to it and try and figure out how profitable these are. The second webinar Wednesday, the third one will be focused, we hope, on second life refurbished turbines. Now, Gareth tells me that South Africa is not keen to import second life or second-hand units. But remember, a lot of our viewers tonight are from outside South Africa, and the likes of Zimbabwe, Zambia, and elsewhere, certainly can do that. They import a lot of second life vehicles anyway. And the problem that we got at the moment is evidently a lot of the repowering done in Germany and Europe, those turbines are being shipped off to Ukraine. The great thing about these smaller turbines is you can fit the blades into a 44-foot container and you can ship them anywhere. So I think we may change the subject there. Okay, now without further ado, I'm going to switch over and introduce Mike Berge to you. He's the co-founder and president of a company, Berge Wind Power, been around for ages and ages. Mike's a mechanical engineer and a recognized expert across the world on small wind systems. He's been working with various organizations focused on those units, and I'm glad to say he's sent us some information. If you have a look at your system, you can actually download a PDF file on one of his turbines. You are also welcome, as we go through the presentations, to contribute via the chat box and ask questions. There's a question area. Please put your questions in there, and we'll go through them afterwards. We're hoping to have a pretty good session there. So I'm going to be handing over to Mike now. Mike, if you could switch your camera on as well. And I'm giving you control of the system.
Okay. All right. Well, first, thank you very much, Mike. It's an honor for me to have an opportunity to speak with my colleagues in engineering halfway around the world in South Africa. I've visited Central Africa a number of times and the Maghreb, the Northern Africa, and haven't found my way back down to South Africa, but perhaps I can come up with an excuse and come visit you. Let's see, I'm trying to share screen here.
There we go, that's coming up.
We have your screen.
See, I just see myself. I don't see my screen.
You should be able to click on the sharing in the drop-down menu. It's got sharing there. You should be able to see fold back on what you're displaying. In any case, your presentation's up. Can you put it into presentation mode, please?
I cannot see it yet. So I'm trying to make another attendee. I am trying to figure this out. I apologize. I see nothing. I see how I can change presenter, but that doesn't. Perhaps if I no, but perhaps if I take away my, there we go. I took away my camera, and all right.
All right, you might be able to put that into presentation mode. If not, please go ahead.
There we go. All right, so it should be in presentation mode.
Brilliant, thank you.
Okay, so sorry about the delay. Anyway, so as a little bit of an introduction, the company that I run is one of the leading suppliers of small wind turbines in the world. We've been in operation for a little over 48 years. Our claim to fame is that our turbines are mechanically very simple, only 2 moving parts and no scheduled maintenance. We have a little over 10,000 installations. We have them in all 50 United States and over 100 countries, including a number in Africa. We have had some turbines that have been in continuous operation for over 40 years. And we've had some turbines that have been operating more than 20 years with no OPEX, no operating costs at all. They've not even been inspected. How do I advance? Okay, there we go. So, and a little on my background, Mike covered it, but I'm a mechanical engineer by training. I've been in the industry over 50 years. I have twice served as president of the American Wind Energy Association, and I'm in the 6th term as president of the Distributed Wind Energy Association. I'll explain that in a minute. And I've been active in our local economic development. I've been president of our local Chamber of Commerce, and I've served on the Governor's Economic and Workforce Development Board. The Distributed Wind Energy Association is the trade association for behind-the-meter wind turbines in the U.S. And so we have about 70 members, and our mission is to increase the business opportunities in our industry. And so we're represented in Washington, D.C. because policy is so important, and we work to get favorable incentives and reduced soft costs to help the industry strive. So distributed wind is defined as one or more small to medium turbines, mostly some megawatt scale, but it's all behind the meter. And so these systems are installed to reduce the operating costs for a facility. It could be at home, a farm, a business. And so as the wind turbine produces electricity, the electricity is first used to support local load. And then if there's any excess instantaneously, that is transferred back to the power grid, and typically the owner is paid something for that, something between a very low number and the retail value of electricity. Without storage systems, these systems shut down during power outages. So some are being installed now with storage, but the vast majority of the distributed wind systems don't have, and therefore are not providing backup power during outages. We have a very large potential in the United States. The installed capacity of all generation in the US is something around 1,300 gigawatts. We have potential equal to that from distributed wind. It's greater than the potential for offshore wind, although it's had far less government and private sector investment. But it's a area of high growth, and the best wind resources and the major markets are in the Midwest, what we call the Central Plains area of the US. So there's not much wind in the US in the southeast part. There's good wind on the West Coast and on the Northeast coast, but distributed wind is primarily used in the middle part of the country. Some good benefits for distributed wind with a moderate to good wind resources. It's a least cost technology, can be cheaper than solar. It has a small footprint compared to solar. Farmers like it because it doesn't take crop land out of production. It's 90% smaller footprint. It complements solar in that it provides power at night and more power during the winter months when typically solar is less. And as Mike mentioned, if you have an electric vehicle, being able to charge it with renewable power at night is a real advantage. And one of the main advantages, I'll show more information on this, is that the technology is not so advanced, and the production is not so sophisticated that it requires a huge investment to set up manufacturing. So the wind systems, unlike solar, can be built locally at much lower costs. So you're all very familiar with wind farms, and that, of course, is the major type of wind energy development. And small wind systems are more expensive. There is an economy of scale. You'll hear about that. But it's important to realize that the large turbines are selling into a bulk power market at wholesale prices. They have to compete with gas turbines and coal power plants, hydro and nuclear. And so the value of the energy they produce is only in the range of 2 to 4 cents, because that's the busbar competition price. The distributed wind, however, more expensive per kilowatt installed, but it's also providing a more valuable electricity because it's offsetting retail electricity, which is typically much, much higher than wholesale price of electricity. So bear that in mind when somebody points out that you have to build large to make the numbers work with wind. I mentioned that solar and wind are complementary. This is a simple graphic that just shows, on a daily basis, you have, solar works very well midday, but of course nothing at night. And so if your utility has a peak that's in the early evening, as many utilities do, wind power can be a more valuable source for meeting that peak. And on a seasonal basis, although they are complementary, wind can also be extremely valuable where you've got high winter loads for heat, for example, heat. So looking at not just the busbar cost of electricity, it's when it occurs that has a factor in its value. I mentioned that wind systems can be manufactured relatively easily, and that's compared to solar, which, if you go into a multi-gigawatt solar factory, it's all robots. The only people are there are the ones that are doing maintenance on the robots, and it's really not very good at creating jobs. Wind systems, on the other hand, you've got generators, blades, structure, you need machinists, welders, painters, and so there's a lot more people involved and less robots. So you can set up a distributed wind manufacturing facility for far less than you can a solar facility, even if you're just doing assembly of cells into panels. The cost of distributed wind is coming down. There's been a lot of research investment from the US federal government into a number of different companies, including my own. The plummeting prices for solar have really caused our industry to do some hard design work to try to drive costs down to remain competitive. An example is our company. Our original or previous generation had an LCOE of 21 cents per kilowatt hour, and the new generation is less than half of that, based upon better engineering. Here's an example of a couple of examples of distributed wind projects in the US. This is a 15 kW at a farm in Nebraska. It was about $100,000 installed, but there were robust federal subsidies that reduced the cost of that to provide a payback period of approximately 2 years. So at this point, that turbine has already paid for itself, and the owner can expect 30 or 40, maybe longer years of lower cost electricity, about 35,000 kilowatt hours per year. And then here's a larger project, 2 100 kW turbines installed in in 2016 for a large dairy operation. These turbines produce 480,000 kilowatt hours per year, which is about 60% of the dairy's annual usage, and it's connected to a rural electric cooperative in eastern Colorado. So I mentioned subsidies. We're fortunate here in the U.S., at least up to this point, in that we've got, this was enacted several years ago, a residential tax credit. A tax credit is savings off your tax obligation, so it's not a reduction in your taxable income. It's an actual credit against your tax obligation. So we've got a residential and a commercial 30% tax credit, but then if it's a commercial operation, there are some bonuses that can be applied if you qualify. One is for domestic content, and one is in what's called an energy community, and those are communities have been in transition from fossil fuel to cleaner energy. You can also claim depreciation for further tax savings. And one of the big things that occurred in the Inflation Reduction Act in 2022 was that non-tax paying entities could then get a direct rebate from the federal government. So churches and rural co-ops, other groups that don't pay income taxes were able to benefit from the subsidies. And then there are grants that are available for agricultural operations of up to 25%. The Distributed Wind Energy Association has a new program called AgWind. We're focusing on agricultural applications of distributed wind. We have a desktop feasibility tool that is actually based upon a Berge Wind Power tool, and we allowed them to license it free of charge and to make it generic for other turbines. And it's a very useful tool in doing a feasibility assessment. It combines a worldwide wind map from Microsoft with a worldwide wind database from Vaisala, and then it's got all of the messy performance and economic computations kind of in the background. And so the user just has to do some simple inputs and can get a report on the payback period and performance and other things that are valuable. If you'd be interested in information on that or more information on distributed wind writ large, I invite you to check out the websites that are hosted by the Distributed Wind Energy Association and learn more about that. So now I'm going to talk a little bit about Berge Wind Power. But before I do, I want to give a shout out to Everready for the Kestrel wind turbine line. Around the world, the Kestrel wind turbine line has a stellar reputation for ruggedness and reliability and performing as claimed. And so I hope that you're proud of your domestic company there. They are a recognized leader in the small wind area around the world. So switching over to Berge Wind Power, we started in '77, shipped our first unit in 1980, and you can see the progression of models that we've had, and we, as you can tell, we got really proud or really liked yellow and white as a color scheme. We've kind of gotten away from that to try to reduce permitting problems, but you could tell a Berge turbine from quite a distance in the past. We've done turbines from 850 watts to 50 kilowatts. We're not producing the 50 now. And we have supplied a number of units to Africa. We've done projects in the Maghreb, Morocco, Tunisia, Egypt, North Africa. We've done a lot of telecom projects in the middle part of Africa, particularly in Kenya and Uganda and Tanzania, Angola. And then we've done a couple of projects in South Africa. I know we did this one with MTN in the Kalahari. I haven't heard from them in probably 15 years, so I don't know whether it's still in operation, but this was a remote mobile phone site in South Africa. That's both of those are Berge 10 kW turbines. So the two turbines that we make today are a 10 kilowatt, 7 meter diameter that we've had in production since 1983. Now it's on its 3rd generation alternator, its 4th generation blades, and 3rd generation power electronics. So it's been a lot of technology upgrades, but the basic machine architecture is unchanged. And then we make the 15 kilowatt turbine, which is our primary product right now, because it's got a much lower cost of energy than the 10 kW, and was developed specifically to compete with Chinese imported solar. The 10 kW, we did about 3,000 of them. Actually, it's still in production. I should need to update the slide, but they were it's been certified in the U.S., U.K., Japan, and has a pretty stellar operational history. Quite a few of them still in operation after 30 or 40 years. But we saw, and the other members of our industry saw, a real decline in sales starting about 2013, and the reason was because solar module prices dropped so precipitously. So you had the Chinese government put in over $40 billion in soft loans. The Chinese built mega factories, overproduced, had to dump it even below production costs, and so while that was absolutely wonderful for the environment and absolutely wonderful for people developing solar projects, it wasn't so good for other clean energy technologies like distributed wind. And we still face a big challenge in China from the Chinese solar industry. They have about an 85% worldwide market share still to this day. So Berge Wind Power saw declining sales and decided that we really needed to do something. We looked at a number of upgrades to the 10 kilowatt turbine and decided we just couldn't catch solar with that. So we started with a clean sheet of paper and went from furling to stall regulation, for example, developed some advanced technologies on the blades that allowed a much bigger rotor on the same size structure, which is the recipe that large wind is used to drive down LCOE. And so the 15 kW, which took about 5 years to develop, has a 9.6 meter diameter. It's got tailored aerodynamics. It can, even though it's got a much bigger rotor, it can go on the same towers and foundations as the 10 kilowatt with over double the energy, and I'll show you some metrics on that in a second. It's got carbon fiber single shot blades, its variable speed with stall control, has only 2 moving parts, has no scheduled maintenance, a 3-year inspection interval, and a 30 to 75 year predicted operational life. And since we have turbines that have been in operation for over 40 years, we've got some basis upon making those projections. And we've paired that with a custom designed silicon carbide switch inverter, 25 kW in capacity, single phase. This is a chart, and I won't go through all of this, of course, but let's look at the highlighted areas. We increase the efficiency by 33% over the previous generation. We increase the annual energy output by 139%, and we reduce the levelized cost of energy or payback period, if you will, by 45%. We went on to develop helical anchoring systems, which had been applied in a number of applications, but never to the concentrated live loads of a wind turbine tower. And so we developed both the design and the sort of procedures on ensuring that you can, without doing an expensive geotech, you can ensure that you've got adequate strength. And that, combined with tilt-up towers, gave us a 2-day install, and that's what our dealers are primarily using these days. They use a skid steer with a torque motor, which you can see in the picture on the lower left, to install those. Typical costs for the 15 kW are about $105,000. We had to raise our prices about 25% when the pandemic-related supply chain and inflation hit. We saw, like everyone around the world, steel prices sometimes doubled, couldn't get electronic parts. So we originally, before the pandemic, the turbine sold for $37,500. We had to raise the price to cover our costs. All the large and small wind turbine manufacturers around the world went through the same pain that we did, and our customers did. We build everything in-house. We build the blades. You can see a stack of the blades waiting to be painted down in the lower left. We build the alternators, they're direct drive, permanent magnet alternators. We build the structure, and we build the electronics in-house. Our primary market these days is the agricultural market in the US. You can see the subsidy stack here, which, so there's about a 90% coverage of the costs, almost 90%. That's been reduced a little bit now because of the current change in administrations, but it's still a robust market for us. And so you'll commonly see a Berge wind turbine at farm shows around the Central Plains in the US. We also have an active market with retrofits of older turbines, Jacobs, Proven, Gaia, Endurance, Evoco, Redriven, a number of different companies that are no longer in business, and you can't get support for the turbines, but the towers and foundations are still good. So that's a good market for us as well. We have, in the US, we have about 150 dealers who do sales and installation. They're, I think, like many dealership networks, it's about 20% are the most active ones and produce the greatest volume of sales, but we are represented. We also have about 20 dealers around the world, and most of them are not very active, but we have not been exporting the 15 kW, but we're going to start doing that this year. And then I had showed the AgWind tool. That's based upon a Berge Wind Power wind report tool, and we supply this free of charge to our dealers and our key accounts. If that's something that would be of interest to you, please let me know. And with that, I will thank you for the opportunity to speak with you today, and I look forward to answering any questions you may have when we get to that part of the program. Thanks again.
Thanks, Mike. Fantastic stuff. Yeah, we hope to see a lot more small wind or distributed wind in this country. I think there's going to be a big need for that. Okay, so without further ado, I'm going to fire up Gareth's system. Let me just click on the right things here. Sorry, Gareth, I'm going to have to take control back so that I can put your display up. Okay, so we're lucky that in South Africa we do have a sound group of engineers working on wind and small wind, most of them based down in the Cape. And when it comes to wind potential, there's nothing like local knowledge to understand where to place the various units. So I'd like to introduce Professor Gareth Erford. He's with Stellenbosch University. He's working with EDF Renewables. His history is touring the world, I believe, and working abroad. And he's completed his doctorate down in Stellenbosch on vertical axis wind turbines. That's an interesting approach. And at the moment, he's working as the lead wind engineer for EDF Renewables, working, of course, with and lecturing at Stellenbosch. He's published a number of papers as well on local wind resources. So that's something that we certainly need to dig into. So now, without further ado, I'm going to tweak the system and hand over back to Gareth. There we go, Gareth. I hope you can share. Thank you.
Great. Does everybody see my screen? And yeah,
Yes,
I also have
thank you.
I can't share my camera without taking away my screen. Sorry. So I will jump straight to sharing, well, straight to my presentation. That's all right.
Thanks, Gareth.
Yeah, so my name is Gareth Erford. I'm a associate professor at Stellenbosch University. That's the hat I'll be wearing today. Thanks for the introduction, Mark. I don't have a about me slide, so the short version is mechanical engineer, passionate about wind, got into wind through my studies, which was on the design of turbine blades, in particular for vertical axis systems, which is not something you see around the world often. They're very far and few between. So now I spend my days doing resource assessment, trying to figure out where the wind is and where we can put turbines. My slides are short and they're a lot less fancy. So hate to be second fiddle here, but I'll do my best. Let's jump straight into it. So before we go into resource assessment, I'd just like to talk about small wind as I see it. We have micro turbines, which are less than 1 kilowatt in size. We have small turbines that can be defined as less than 150 kilowatts, or systems up to 100 kilowatts in size, made up of multiple turbines. And while South Africa doesn't have a large small wind community, I have to say it with tongue in cheek, because we have 100,000 or more than 100,000 wind pumps in operation over 45,000 farms in the country. And while they're not producing energy, or not all are producing energy, they're probably being used for farming life, such as borehole pumping or moving water around. That does sound like a lot of wind pumps, but we don't have the distributed wind community or fraternity as you've heard about in the USA. The image at the bottom is to give you a sense of scale. If you were to put up a 1 kilowatt turbine, we're talking around a height of 15 meters. If you had to put up turbines closer to 15 kilowatts, which would facilitate a farm or business, that's about 50 meters up in the air. So small wind can go up to 30 meters high. And micro wind, which is something for residential, you could probably get away with putting that up in your garden. South Africa is blessed with a great wind resource, mostly here along the coast, not so much up north, but there is definitely great wind around the whole country. And if you're on the coast, you can get wind speeds greater than 9 meters per second on average, which is classed as the best kind of resources available for wind turbines. This map that I'm showing you comes from the Wind Atlas of South Africa. It was made in 2020. There have been 3 iterations of the Wind Atlas of South Africa. It is free to download, publicly available, and a great resource for anybody local. I did hear that there are people from outside South Africa on this call or on this webinar. I apologize, but it's going to be very specific to where I am and the resources I have on hand. So I've mentioned the word resource more than once. While we've heard talk about how small wind operates or the small wind manufacturing in the States, I'm going to look particularly at how can I get a small wind turbine, or How can I leverage small wind in my neighborhood, my area, on my property? The first thing you got to find out is, do you have enough wind to make it a bankable case? There are free data sets available. So if you do not have money to put out a meteorological station or weather station, as depicted on the right-hand side, that is a Davis weather station. It is capable of sending information, I think, up to 10 or 20 meters away from the vane itself. So you can put that on the far side of your property. You have a terminal that can connect straight to a computer, and you can log what the wind is doing, what the sun is doing, what temperature is, and all the other nice fancy things that you need to identify weather conditions. If you don't have money to fork out for a weather station, you could go a cheaper route and look for free data. Free data comes in various forms, the most popular for academics being ERA 5. ERA 5 is a data set that provides wind speeds at a height of 2 meters, 10 meters, and 100 meters. 100 meters definitely not what we talk about when we think about small wind, but the 2 meter and the 10 meter are useful. This data set, though, is not local, it is international. So you have a data point, or you have wind speeds and temperature every 31 kilometers around the globe. That's great if the data point happens to be near you, but not so nice if you're in between two data points. So you won't have the information about what's happening at your house, for example, but you might have information that's happening 30 kilometers away or 15 kilometers away. So that's ERA 5, and I did show you the WASA map earlier. The link at the bottom is for where to get South African data covering that WASA map. So you can get information every 3 kilometers in the same format as ERA 5 at different heights though, so not 2, 10, and 100. I think it starts at 50, 100, 120, 200. So higher values or higher heights, but also one low height, which is quite useful. You might have a med station, you might not. You might have gotten the free data that I just mentioned. But what if you can't get any of that data? Somehow you're in a position that doesn't have WASA data on a high resolution, or the ERA 5 node is too far from the area of interest. You could just look outside and tell me, what does your tree look like? Presumably, if you're putting up a wind turbine or thinking about putting up a wind turbine, it's in a windy area. But how much wind is windy? So this image comes from a PDF highlighting small wind and how to put it into property. And it's more of a thumb suck method, which is what mechanical engineers like, back of the envelope calculations. If you have a tree and you don't see deformity, that's a 0. If you have a tree and you see a lot of the branches leaning towards the right-hand side, completely flagging in this case, that's class 5, which can estimate our wind speed to be between 7 and 8 meters per second. This kind of resource is definitely not bankable, but it does give you an idea of, should I even look into wind? Are any of the trees or any of the branches in my area, in my neighborhood, on my farm, showing signs that there's strong wind? That's good enough to start the investigation, in my opinion. Mike mentioned the profiles and how wind can complement solar, how wind changes during the seasons. The reason we do resource monitoring, or we try and identify with the weather station or with the free data sets what kind of wind we have on site, we'd like to know which way the wind is blowing. We do that through wind roses, as you see in the center. We also identify how the wind changes over different seasons. So you have an average wind speed, but you have maybe more wind over winter than summer, or more wind at a different time of day, such as along the coast where you have sea breezes. So you have a very cyclical wind cycle over a 24-hour period. And you like to know these things because then you also can identify, will this supplement a solar system on my house, or do I just have enough consistent wind to go without solar? The graphs on the right-hand side are ways to identify or replot the information. Wind speeds typically can be represented with a rally distribution curve, which is this distribution over here. I don't know, can everybody see my mouse? I'm assuming so. This distribution highlights what is the wind speeds that we get most often. In this image, it is the 4 meters per second wind speed, but also tells us how often we get other wind speeds, such as 6 meters per second or 2 meters per second. And that's useful to identify what kind of turbine gets put up in your area. So we've gotten a location, a farm, a house somewhere where you live or want to put up wind, where you have property or have a load requirement. Is this actually possible? Well, in South Africa, as mentioned, we have the Kestrel manufacturers. They are local, they're based in Gqeberha, and they have a range of turbines from 600 watt, which is our microscale, up to 3.5 kilowatts, the E400 NB. These turbines are, as we said, locally manufactured, built indoor, built in-house, and thankfully, we just heard, have a great reputation overseas. So I think they're rather trustworthy. I personally don't have any affiliation to them, so I'm not punting them, but I do feel that it's a local brand and it's worth investigating should you wish to pursue. All right, we have wind resource. We have a turbine that we can use. Bergie excluded, can be used obviously, but I just mentioned Kestrel. Where do I put it on my property? So there's a general rule of thumb that you don't want to be near your house or near obstacles to slow down the wind. As your wind approaches obstacles, it slows down, or as the wind goes over large flat array or large pieces of property, large pieces of building, it slows down or becomes turbulent. So you're trying to adjust the position of your turbine so that it doesn't fall into this exclusion zone. If your obstacle, for example, the height of your house has a value of H, you would like to have your turbine at least 2 times H above the ground level and 20 times H away from the obstacle downwind and 2 times H away from the obstacle upwind. Identifying upwind and downwind is simple. It comes from the windrows that we talked about using the Met station. All right, I've got a large piece of land, I've got wind in my property, I've got this turbine in hand, I can put it up on the corner of my property because it matches the restrictions or the exclusion zones great. Am I legally allowed to do it? I focus particularly on the Cape Town municipality, City of Cape Town bylaws because, well, this is where I am and this is the information I have on hand immediately. There are typically rules restricting what you can and cannot do on your property as to how high you can build things or what you can put up as close to the boundary wall as possible. City of Cape Town has proposed updates to their bylaws. One of the updates would allow for a horizontal rotor access, such as the Bergie wind or Kestrel turbines we just shown, if they were less than 3 meters in diameter and the blade length has less than 700 millimeters. It can be a maximum of 2.5 meters high and should be at least 2.5 meters away from the boundary wall. That's very restrictive, but that was one version of the bylaws. I found another version which said that it shall not be less than 5 meters away and can be lower, must be lower than 1.5 meters above the roof of your building. So what the final laws are depend on where you are and what's been published. I've only managed to find these two very different sources of information on what the bylaws in the City of Cape Town are. But before you even purchase a turbine, you need to understand what am I legally allowed to do before somebody comes down and gives me grief about trying to get some wind energy. All right, I rushed through that, apparently. I do apologize. But thanks everybody for listening, and I hope I can answer some of your questions or I've piqued your interest about how to get wind in or around your area. Thank you.
Thanks, Gareth. Now we come to the questions, and we've got a number of questions that have been sent to us over the last couple of days, ever since we've been promoting this series. And just a reminder to those of you who are going to be logging out now for dinner, perhaps, don't do that. There's going to be a lot of interesting discussion. And of course, in the bottom left-hand corner is a QR code for the Institute's TV channel over at YouTube. So you're more than welcome to go back and watch any of these webinars there as well. Share with your friends, please. Okay, so the questions we believe we're going to be of interest. I'm going to ask my colleague Henry Karosky if he would just take over and read them out. If you can switch on your cameras. Henry, you got your questions ready, perhaps? There we
Yes,
go.
good evening, everybody. We have the questions ready for you that have been sent through in the past or during the registrations. First one, to our panelists, what size turbine would be appropriate for a site's energy needs? And would it be a single large unit or many small units?
May I jump in, or how would you like
Yeah,
to?
go ahead, Garth.
Just
Garth.
go ahead,
Go ahead.
guys. Jump in.
Yeah, so that's a very, well, almost impossible question to answer. Every site is different and every load is different. So are you talking small residential? One turbine can help. Are you talking a farm? One large turbine can help. Or are you talking a community, such as discussed by Michael earlier? Then it would have to be multiple units. You would first have to identify your load profile and the resource available to you to see what your turbine setup should be.
Yep, I agree. Now, but I'll add one thing. Typically, for excess generation, that power that you produce and not able to use on site, you're not going to probably get paid as much as the retail value. So there's an incentive to not oversize a behind the meter system. So as Gareth said, figure out how much electricity that building or facility is using, and the wind resource, and then there are companies and consultants who can help you match the right size turbine or turbines to that need.
Yeah, a comment from me. I would think in the South African situation where we have power reliability issues, that battery energy storage systems would be a natural fit to go with us.
Right, and that's certainly a strong trend right now. The cost of storage has come down enough that microgrid systems are becoming much more attractive. Also, the state of the art in power electronics is delivering not only grid following inverters, but grid forming inverters at reasonable prices. So you see a lot of particularly solar plus storage systems that are on the market now, and what's coming along behind it is wind plus storage microgrid systems. Because of climate change effects, there's a lot more severe storms, longer power outages. People are more concerned about power surety, and even though we've got reliable utilities in the U.S., there are a lot of power outages due to things beyond the control of the utilities. So we definitely see that coming down the pike and becoming more affordable to where people can think about that as an alternative to a home standby generator or a backup generator like a Caterpillar generator.
Thanks for bringing the context to South Africa in that we don't have the most reliable electricity supply. What would be interesting to note is the small-scale embedded generation requires you to be licensed or registered with NERSA or with your local municipality, and then through NERSA. And in doing that, they have requirements on the inverter that you have attached to your grid so that you don't damage the grid system itself. So what you're trying to identify is a small wind turbine that can connect to a acceptable inverter system that has batteries attached to it as well, or solar. And that combination is not easy to come by. Again, Kestrel's managed to have a model that fits directly into an accepted inverter in the city of Cape Town with the sun sinks, and then you can either trickle charge your batteries overnight when the solar is not around, or if you have a big enough space, you can actually run full charging your battery or your system as needed. So in terms of security of supply, distributed wind makes a lot of sense to aid when the sun goes down in those areas where wind is available.
One of the things that we're seeing is a more interest on the part of utilities in wind plus storage systems, even though it's competitive with them and they sell less electricity. The ability to dispatch those wind and storage systems to do peak shaving is extremely valuable to them, particularly in areas with high load growth. They're starting to see what's called virtual power plants are becoming very popular, and we've got some good-sized projects in the works that would put hundreds of systems out, and the utilities would be able to turn them on remotely during peak power, and therefore reduce their peak demand, or help supply their peak demand, I should say.
Thank you, gentlemen. I think that's covered that fairly comprehensively. The second question is, Mike, I think you've answered already fairly comprehensively, but I'll put it out there in the meantime. How long can I expect a small wind turbine to last, and what kind of maintenance will it require over its lifespan?
One of my favorite topics. So a wind turbine is a mechanical, it's a machine, and there's a lot of differences in design philosophies and quality of the engineering and quality of construction. And it's something that requires you, the customer, to do some shopping. So there are turbines that have not lasted very long. The certification programs that were mentioned at the very beginning have been very helpful in sort of sorting out the wheat from the chaff. And so a certified turbine, and there are international standards, and they're not just US standards, the IEC standards. So if you can find a turbine that is certified, you've got a much better shot at having a long-lived turbine. But you know, there are different trade-offs. So a direct drive generator instead of a gearbox and a high-speed generator is more expensive to build, but requires less maintenance. So it's just like in large wind, there are direct drive machines and there are gearbox machines, and it's sort of up to the shopper to decide what's best for them. But you can go 20 to, some of the Jacobs wind turbines in the US were in operation for 80 years with minimal maintenance.
That's impressive.
Yeah, if you can make it survive the storms, it'll have a long fatigue life, is the bottom line.
And the follow-on to that, again, you've answered to some extent. What are the typical costs associated with installing and maintaining small wind turbines on a typical farm? And what's the relation with CapEx and OpEx?
Right. So, you know, different manufacturers have different prices. There's each installation is a different construction job. The wire run differences are different. The soil conditions are different. Logistics are different. Rough numbers, anywhere from $3,000 per kilowatt installed up to about $8,000 per kilowatt installed before any subsidies, and then and that's going from a couple of kilowatts, or say a single kilowatt, to 100 kilowatts, and then and larger machines are less expensive, the megawatt scale, and then operating costs can be as low as amortized about $100. I'm not sure what the exchange rate is, but $100 US per year, on up to, you know, a couple of thousand for a medium scale machine with a gearbox and lots of sensors, grease fittings, things that need to be worked on, like the large turbines do. Gareth, you have an
yeah, from the South African market, the turbines are costly, and I hate to do this because I support turbines, but if you had to purchase the smallest Kestrel in the range of probably 30,000, which is a 600 watt, so 30,000 Rand for 600 watts, or you can buy a PV panel for around 2,000 Rand for a 500 watt, which is vast difference in numbers, but the life expectancy is the biggest difference. That panel is not going to last as long as the turbine, and the time of use is definitely different depending on where you are. So you could pay back your turbine significantly faster along the coast than if I was, say, in the middle of the Karoo where the sun shines more easily and I'm going to have probably less consistent wind. So I can't speak to operational expenses, but capex wise, it's rather costly per kilowatt.
I'll point out that if you have an off-grid system, not connected to the grid, a combination of wind and solar into a hybrid system can reduce the size of the battery system that you need, and can increase and reduce the amount of diesel backup power that you need, and reduce the payback period. So hybrid systems with both solar and wind for off-grid makes a lot of sense.
The next question actually is a great one. The insurance companies are now starting to look at solar quite closely, and in some cases not favorably. What are the insurance implications of installing wind turbines?
So I don't know the nature of insurance policies in South Africa, in America and Europe. A homeowner's policy or a farm policy would have a separate category for associated or appurtenant structures. So a barn, an outbuilding, a garage. And so a wind system is typically covered under that as an accessory structure. And while it's a smaller percentage compared to the home or the farm, overall, it's enough to cover reasonable damage that might come from a direct lightning strike, or from a very severe hailstorm or something like that. Manufacturers offer warranties typically in the 2 to 10 year range.
Mm-hmm. Prof, do you have any comment relating to South Africa?
Unfortunately, I would be lying if I knew anything about insurance related to turbines, so I'm going to keep my mouth.
And we have a question regarding the effect of wind turbines on farming operations with respect to interference, noise, defrosting, and crop dusting, and the effect on wildlife, birds, etc.
Right. So
it's quite a broad question, but perhaps we can take a look.
I'll see if yeah. So in terms of taking up space, that's one of the main advantage of wind over solar, is that the footprint is far less. So typically you can find a place within the farmstead where it's not being used for production, it's not a roadway, and it's a place that where it's not interfering with operations at all. A farm-sized turbine is going to be in the 30 meters to 50 meter height, total height, and of course that wouldn't be good for low-flying spray plane, but these are pretty obvious structures, and the pilots are quite good. There have been fatalities from ag pilots from meteorological towers because they're very slender, they have guy wires, and they can't see those. There has never been a injury or accident related to a distributed wind turbine from a spray operation. The small wind turbines have been installed at national parks, wildlife refuges. They've been closely monitored for bats and migratory birds. The U.S. Fish and Wildlife does not consider distributed wind a threat to species, and so there's really not a concern about raptors or songbirds or bats with small to medium wind systems. There's no pollution, there's no water requirement. So environmentally speaking, the wind systems are good neighbors, and they're installed at thousands of farms around the world.
I can echo that sentiment just by saying the impact is negligible if measurable. At the height at which we're installing small wind turbines, they don't impact any of our avifauna. The effect on grazing animals is even less, where some advocates have said that the turbines create a noise that disturbs animals. I've personally seen that they gravitate towards the pylons, probably just follow the shade around, but they don't honestly mind the turbine spinning. And the noise itself is significantly less than the utility scale turbines. It's a different kind of noise. The utility scale is more of a thumping whoosh, whoosh, whoosh. There's the small turbines have a higher frequency, but it's not something you're going to hear over wind. Like if the wind is blowing and the turbine's spinning, you're hearing the wind before you hear the turbine. So the impact on the environment and the effects on people is very negligible.
So we're looking at a very different scenario for the small turbines and utility scale.
Yeah, with the utility scale, this is thanks to the DFFE. There's a rigorous environmental impact assessment that you need to go through. It is not the same for a small wind turbine in this case.
Okay. Okay, gents, we're on to the questions that have come in live. Okay, the first one is actually answered already. What mitigation measures do you have in place to curb bird collisions? I think you answered that. How do you provide maintenance support for countries in Africa?
Well, of course, if you purchase a Kestrel system, you have a local manufacturer and a local capability. For a foreign or an imported turbine like ours or someone else's, we sell through dealers. So we'll set up a dealership, electrical contractor, a very common business that we have as dealers, and they can provide both the installation and the after sales support. We really don't just do mail order sales and ship turbines off unless somebody is a trained engineer or has clear construction capabilities. These are big erector sets, but there's a lot of stuff that can go wrong, and they need to be installed correctly in order to operate efficiently and for a long time. And it's a skill set. So you want to look for a local partner to buy from.
That makes a lot of sense, and I would imagine that's how most of the manufacturers and dealers operate.
Well, not the Chinese. They will happily send you whatever you want, and you're on your own at that point. So, but look for certified turbines. That's a really good way to reduce your risk.
That makes sense. Next question, we have another question about noise levels, which you've answered. How are noise levels and low wind levels in urban areas dealt with, and how is grid integration requirements achieved? I think the grid integration is kind of universal to all behind the meter generation. Not specific to wind, but if you'd like to comment on it, please do. And the noise levels and the low levels of wind in urban areas, I think you've already spoken of, but perhaps you'd like to comment on that.
Yeah, so the noise levels, the reason that you have the bylaws stating where you can and cannot put a turbine on your property is to account for those noise levels. Obviously, it's a one-shoe-fits-all approach, so they've been rather restrictive by saying you can't be on the boundary wall because that will affect your neighbor, and you can't be too high because that's a visual impact as well. So the bylaws in place in your particular regions account for the noise levels. What that noise will be depends on, one, the turbine you're buying, and two, where you're placing that turbine relative to yourself. So you can actually get instrumentation set up to measure that. And then very little to comment on in terms of the grid integration. If you've got your inverter and your solar set up, as long as the inverter can take a wind load, then you can use the same inverter setup, and if it's done by the certified professional, obviously.
I'll just add, in our experience, unless you're talking about micro turbines, a kilowatt or less, they really don't go in urban areas. We certainly don't recommend rooftops, high turbulence, vibration, noise issues. They can go in urban parks and in open spaces. But what we found over decades of installations is that we recommend for a home or farm size system, say 5 kilowatts or greater, you want at least 2 hectares. The owner should have at least 2 hectares of property, so that that places the turbine. I'm sorry, 1 hectare. That's about equivalent to 2 acres. It places it at some distance from the neighbors. The turbines do make some noise. It's like a air conditioning system, sort of. And it's particularly noticeable at low winds. In higher winds, the background noise of the wind itself masks the sound. But keeping some distance from your neighbors is a good policy.
We have a question here about integration, and specifically the Kestrel wind turbine. How does it combine with the SunSync inverter?
So SunSync has various inverters. There's actually a video posted by SunSync and Kestrel in combination where they describe that their turbines link straight into any of the MPPT ports of the SunSync inverter. So there's no need for an additional break or any kind of additional programming system to make sure the load is followed. It's plug and play. I'm not sure on the full electronics, but basically there is nothing in between. If you got your turbine up and you have the inverter, you can connect them directly to each other.
Yeah, I would think it could also, if it's a small turbine, go into the smart input, because I think most of the SunSyncs have one.
There's a dump load feature which you can also go into if it's not going to use one of the MPPTs.
And that is my thought. A question here about distributed wind systems, and what is the effect if it's located close to utility scale facility? What would be the key considerations?
Well, of course, all turbines produce a wake, and so a rule of thumb for spacing turbines is 8 to 10 rotor diameters downwind in the prevailing wind direction. You want to give the wind a chance to recover before you put it through a second rotor. So in amongst wind farms, if it's short enough where the rotor of the small turbine is below the rotor of the big turbines, then that's not as much of an issue. But I think you want to follow industry rules of thumb on spacing otherwise.
Here's an interesting one. What maintenance would the blades require over the life of the turbine?
So that depends on a couple of things. The tip speed that they operate at, how much dust or bugs are in the air, and the way the coatings that have been used to protect against abrasion. So it can be an issue, but I think in the small wind industry, there's a lot of experience with long-lived blade life, and I think the main tier 1 suppliers know how to protect the blades for extensive periods. There are polyurethane leading edge tapes that are used sometimes. I know Bergie Wind Power learned a powerful lesson putting our first turbines into Scotland with high rainfall and very high wind conditions, and discovered that our leading edge protection tape on the 10 kilowatt was insufficient, and we had to develop a stainless steel leading edge for those particularly tough environments. But I think you can rely on, if we've got a certified turbine, I think you can rely on the manufacturer to have dealt with those kind of vulnerabilities.
That's an interesting comment you had of the stainless steel leading edge.
Right. So you wouldn't think water would beat up a pretty a fiberglass or polyurethane structure, but at speed, water can be a droplet can be fairly damaging.
The next question, I think, really falls into utility scale, but is there a future for offshore wind in South Africa?
I'm going to pass on that one.
Well, now you're just playing with my emotions. I mean, personally, I hope so. There's definitely good technical reasons for it to go that way, but it does not fit in the small wind category. The machines would be enormous. So I think so. That's the short answer. And happy to talk about it if anybody actually wants to discuss that, but let's not overrun this forum with the wrong information.
And finally, what do the foundations look like? I think Mike, you gave us a little bit of an answer there with your
so I mean the conventional, most turbines are installed with concrete foundations, and there's some clever ways of reducing the amount of concrete work or form work, labor, but typically it's been one of the most difficult aspects of it. Probably the most difficult aspect of installing a wind system is because it's concrete work is difficult and expensive, and it takes time for the concrete to cure to sufficient strength, and so it delays the installation process. That's why we developed helical anchors that can just be screwed in much faster. They don't work in all soils. If you've got shallow bedrock or a glacial till with big rocks, it doesn't work so well. But we found for most installations at our scale, this is at 15 kilowatts and typically 30-meter towers, it works about 95% of the time. But yeah, concrete is the most common, with a lot of steel reinforcements in it.
Well, gents, thank you very much. That's all the questions we have for you. If I can hand back to Mike, I'm not sure if we still have him.
Yeah, no, thanks, Mark, Gareth. Thanks a lot for your contribution. We're going to be leaning on you because our next webinar on the 5th of March this year, again on a Wednesday at 6 in the evening, we'll look at profitable small wind turbines, and I'm going to be driving that. I'm going to be attempting to show, using various techno-economic analysis packages, that we can make these small wind turbines contribute to a system with solar storage. We're going to throw in a diesel genset as well and see how we can combine those and optimize them to give us the right sort of pricing. We'll have time of use tariffs for the industrial park. We'll use the agricultural tariff for the farm. and we'll put these units in. So there'll be two case studies using South African numbers, using South African costs. I'll be leaning on Mark to get us some OPEX numbers. CapEx and OPEX are the sort of numbers we need. And hopefully we will get some pricing out of Kestrel. We certainly need to get them on one of these programs as well. And we're going to try and understand how to combine these various DER resources and get them singing and dancing together. So I think at this stage then, we'll refer you back to the circulars that will go out, the publicity. You'll see something in the press very soon on the 5th of March event, and then another one on the 2nd of April. And I certainly hope you'll be able to join us. Again, thanks to Minx from the Institute for setting all of this up. And Mike, Gareth, I know Gareth, we kept you away from dinner. Mike, we probably got you up way before,
No,
way
not
before
at all.
breakfast, maybe.
No, not at all.
Thanks so much for taking the time to spend it with our audience. I see we still have 70 people logged in. That's pretty good for this time of night. I'm hoping that they got good value out of this. The recording will be up in the channel, the Institute's YouTube channel. Please, you're welcome to email questions to the Institute via the emails provided. Any further questions? We will have a summary of all the questions asked during the time and the answers given. We'll transcribe that. As you know, we've got artificial intelligence that does all these things for us. So we'll turn words into the spoken word into text and email that out. And with that, I think, Henry, any closing comments? Mike, Gareth?
No, I appreciate the opportunity, and I wish you every success in applying distributed wind in South Africa.
Thank
yeah,
you.
thanks
Gareth?
for the invite, and it's been great to hear the input from Michael, especially all the work that he's done. So thanks for sharing all your knowledge with us, Michael. And I'm glad I had the opportunity to talk about what I enjoy. So thank you.
Yeah, absolutely.
Yeah, just
Good show. Thanks, guys. Thanks, Henry.
Okay.
We'll see you later. Thank you. Good night.
Good night.
Good night.